Welcome back. Izzy wanted to say hello, right? Say hi, Izzy. She likes pencils also. Do you want to do some math with us? Yeah? Okay, maybe later. All right, so welcome back. Today we are going to graph some ratios and we're going to talk about using repeated addition and subtraction to find equivalence. And we are starting on page 277. So let's take a look here. Oh, Jack is making juice. Fabulous. Jack is making apple celery juice. Okay, Jack, seriously? Apple celery. That sounds disgusting. But that's really not the point, I guess. Here's Jack's apple celery juice. So he has 25 celery sticks. If Jack uses all 25 celery sticks, how many apples will he need to make the juice? So the ratio here is 5 celery sticks to 2 apples. All right, so it's 5 to 2. And if you look at this table, they used repeated addition to complete it. So we started with 5, so they just added 5 each time to complete the table. And for apples, they started with 2, and they just added 2 each time to complete the table. And now they've got the equivalent ratios, counting up. And then they used those pairs of numbers for ordered pairs and put them on the coordinate plane or the graph, right? So here are the points. You see the blue dots are the points. And then they've shown you how on the graph you can see also that each time they've gone to the right 5 and up 2, to the right 5 and up 2, to the right 5 and up 2, all the way up. And then when you look at that, Jack needs 10 apples to make the juice. All the way up here, find that point, and it's 10 apples. All right, let's look at the next example. Graph ratios using repeated subtraction. So Tyrese lives 10 blocks from the library. He walks 3 blocks every 2 minutes. Wow, he's moving toward the library. How far is he from the library after 5 minutes? Use repeated subtraction to complete the table. So with this one, they're talking about the distance getting shorter. So they're going to use repeated subtraction. All right. So the time to begin with, he's just standing still. He's about to leave for the library. The distance is 10 because the library is 10 blocks away. And then after 2 minutes, now the library is only 7 blocks away. It went down 3 blocks, which fits with the ratio, right? For every 3 blocks, it takes him 2 minutes. So after 4 minutes, he's only 4 blocks away. After 6 minutes, he's only 1 block away. Okay, so how far is he from the library after 5 minutes of walking? Well, 5 minutes is in between here. It's not on the chart, so how would you find that? Let's start by plotting the points. You can see they put them on the graph. The first one is 0, 10. The second one is 2, 7, and then 4, 4, and then 6, 1. So you're going over 2 and subtracting 3 each time. Now, even though we haven't plotted a point for 5 minutes, if you drew your straight line and then went to 5 minutes along the bottom and went straight up from there, the place where that point would be 2.5. So the point 5, 2.5 shows that Tyrese will be 2.5 blocks from the library after walking for 5 minutes. Okay? Try it. How would the graph change if Tyrese walks 4 blocks every 2 minutes? What do you think? How would it change? Well, you just would go through those points and they would be 0, 10, 2, 6, and 4, 2. Okay, let's look at the next page. You can use ratio tables and graphs to show equivalent ratios. We know that. When ordered pairs representing equivalent ratios are graphed as points in the coordinate plane, they form a line. We talked about this, right? How that line is straight because the ratio stays the same even though the values change. If they didn't stay the same, you'd have a different looking line. It wouldn't necessarily be straight. It could go up and down. It could be curved. Okay, so here is our table. The tennis rackets sold. For 3 tennis rackets, they sold 4 tennis balls. 6, they sold 8. 9 rackets, 12 tennis balls. 12 rackets, 16 tennis balls. And then you can also find points that aren't necessarily on there by using the graph and figuring out exactly where those points would have fallen. Okay, do you understand? How can you use tables and graphs to show equivalent ratios? Look for relationships. In example 2, how could you use the graph to find the number of apples needed for 30 celery sticks? So go back, that's the one about that delicious sounding juice. Go back, because we got up to 25 celery sticks. How could you use this graph to figure out 30 celery sticks? Okay, and how could you use repeated addition to show ratios equivalent to 1 to 3 on a graph? Okay, so for those ones, do them and then come back and check your answers. All right. Repeated addition or subtraction to complete tables, then use the values for coordinates on the graph. So it's just what we've been doing, right? Now, go right 5 and up 2 from point 25, 10, because we know we need 5 more. Is it 5 more apples or celery sticks? 5 more celery sticks and 2 more apples. So you just go up another 5 or over another 5 and up another 2, and you would find the next spot. Okay, how could you use repeated addition to show ratios equivalent to 1 to 3 on the graph? Graph 1, 3, and then go right 1 and up 3 as many times as you needed. Okay. So let's look at the rest of this page. Do you know how? Complete the table to show equivalent ratios representing a cost of $8 for every 3 boxes. Then write the pairs of values as points to be plotted on a coordinate plane. Okay, so complete the table and then write those pairs of numbers as ordered pairs. Now, plot the equivalent ratios 3, 4, 6, 8, 9, 12 on the graph, and use the graph to find the number of nonfiction books purchased if 10 fiction books are purchased. So you've got these points, right? And you're going to plot those. And if you look at the graph, fiction books, the number, that's along the bottom on the x-axis. And then on the vertical, the y-axis, it's the nonfiction books purchased. So fiction, nonfiction. And we know the first number in the pair is on the x-axis. So using that, plot those points and then see if you can use the graph to figure out 10 fiction books, which is not one of the points that you plotted. Okay, so complete those and then come back when you're ready to check your answers. Here we go. So we went 3, 6, 9, and then 12. And then, oh, this should have been 15, not 16. And then for the cost of boxes, 8, 16, 24, 32, and 40. All right. Now, for this, I plotted those points. There's my 3, 4, my 6, 8, and my 9, 12. But I had to figure out how many for 10 fiction books? So I'm going to go here to the 10 and then go straight up. And where would I hit that line so that it stays a straight line? At 13 nonfiction books. Okay, good. Now we have one more page today. And that is the very next page, 279. Okay, here's some practice. In 6 and 7, complete the table and graph the pairs of values. You guys know how to do this now, so go ahead and do that. And I think you can also do number 8. A student runs 2 minutes every 10 minutes that she walks. Complete the table and graph the pairs of values. And then it asks for how long would the student walk if she runs for 7 minutes. So this is another one of those ones that it's one of the points, it's not a point that you have plotted. So you have to use the graph to figure that out. Okay? Why don't you do those 3 problems and then come back and check your answers. Alrighty, here we go. So for this, the missing points are 6 and 9, and your graph should look like that. For number 7, 35 and 14, and your graph should look like that. For number 8, the missing points are 6 and 30. Your graph should look like that. And then for how long would the student walk if she runs for 7 minutes? 35 minutes. Okay, now, last part of this page. A car magazine reports the number of miles driven for different amounts of gas for 3 cars. Which car travels the farthest on 1 gallon of gas? Explain. So, you've got some information here on the graph, and you have a lot of the values filled in the table, so you have to complete the table and then evaluate. Here's some information here. So this is car C's gas mileage on a graph. This is car A's gas mileage in a table that you have to complete. And here's just a statement about car B. So you've got information about each of the 3 cars. Which car travels the farthest on 1 gallon of gas? And explain. So first I would complete the table, and then I would compare the information. Okay? Try that one on your own, and then check back and see how you did. Okay? So I completed the table. So 25 miles for 1 gallon, 100 miles for 4 gallons, 200 miles for 8 gallon, 300 miles for 12 gallons, 400 miles for 16 gallons. And that's for car A. And for car C, if I look at the graph, I can see the miles per gallon. And then I have this piece of information here, which is really, it's 1 ratio, right? It's 140 to 5. So, excuse me. So then I'm just going to compare, and what I found was that it was car B. And I compared how far they can go on 1 gallon. So I brought the ratio down on this one, divided both sides by 5. And for this one, I have 381, so I could divide both sides by 3. And I found that car A went 25 miles in 1 gallon, car B went 28 miles on 1 gallon, and car C went 27 miles on 1 gallon. So car B gets the most gas mileage. All right, you guys, good work. Hope this is making sense. Stay focused. We're almost there. You're doing awesome, and I will see you next time. Bye.